All right, friends, it's our last Redemption Day video. We're talking about factoring when we have the sum and difference of squares and the sum and difference of cubes. So the first thing we're looking at is this one right here, a squared minus b squared. So if you have two terms in your polynomial, so 1, 2, and they are both perfect squares, so a is a perfect square and b is a perfect square, then it will always factor into this form right here, a plus b and times a minus b. And then the other form is if you're adding two perfect squares, so the second one right here. So again, if you're adding two perfect squares, so a, your first term is a perfect square, and b squared, your second term is a perfect square, then it will always, always, always factor into this form right here, a plus bi and a minus bi. Notice that when you're subtracting, this factored form doesn't have an I, but when you're adding, this factored form needs the I. If you were to distribute and make it go back and look like the original, you need that I for that to happen. So when you see plus, you're adding an I to the b when you factor, okay? And then most importantly, before you start these problems, you always look out for a greatest common factor. Which we abbreviate as GCF. So when your math teacher is always saying, does it have a GCF? Does it have a GCF? Does it have a GCF? That's because you didn't find it or you didn't look for it. So make sure you're always looking for it. When I start this one right here, I see I have two terms, and I'm going to look at those two terms a little bit more closely. So 2x squared and 72. Our first step is we look for our greatest common factor. So they don't have any variables in common. Only the first one has an x. But 2 and 72, both of those numbers have a 2 in common. So your greatest common factor is going to be 2. Greatest common factors just means you're dividing it out from the original problem and then putting your result inside the parentheses. So when I take 2x squared and I divide it by 2, that gets me an x squared. When I take 72 and divide it by 2, that gives me a plus 36. So now you're looking inside your parentheses. The GCF is just going to come along for the ride. Does this x squared plus 36 match one of these formulas? Because we all know x squared is a perfect square, and we all know 36 is a perfect square. So remember, perfect squares are a number times itself. So to get x squared, that's x times x. To get a 36, that's 6 times 6. So those are perfect squares. So it's matching this formula right here, a squared plus b squared. So I know in my future, I'm going to have my GCF of 2, and then in my parentheses, I'll have a plus and a minus, and my b term is going to get an I. So let's see how we can fill this out. So this first term, x squared, that's like our a squared. This second term, that's like our b squared. So to figure out what a and b are to fill in our formula, we're going to take a squared equal to x squared and b squared equal to 36. And let's get a and b. Let's solve these two little mini equations. So to get rid of a square root, or to get rid of a square, we square root. So those cancel, leaving just a. And this cancels, leaving just x. Same thing with the b squared and the 36. The square root of b squared is b, and we know the square root of 36 is 6. So now we know what our a is. Our a is x, so we're going to fill that in. So that takes up the first spot in your parentheses, just like this formula shows right here. And then your b value, that's 6, that's going to be in your second spot. So this whole thing factors into 2 times x plus 6i times x minus 6i. And that's your sum of squares. But what if it was subtraction? So now you have a difference of squares. What do? So this one here, again, I'm looking at x squared, I'm looking at 49. Their GCF isn't bigger than 1, so you don't have one. You're just going to start factoring. So we know this is going to factor into our first parenthesis with a plus and our second parenthesis with a minus. Notice I'm not using an I because this is subtraction. We don't need an I in there. And now we're going to do the same thing we did before. Are these perfect squares? We know x squared is a perfect square. And we also know 49 is a perfect square because 7 times 7 makes 49. So again, let's set up our two little mini equations. So a squared equals x squared and b squared equals 49. And we're going to square root both of these. So when we square root a squared, that's an a. When we square root x squared, that's an x. When we square root b squared, that's a b. The square root of 49 is a 7. From here, you're just subbing it into your formula. We know a always occupies the first spot, so if a is equal to x, x goes in the first spot. And then b always goes in the second, so b is 7, so x plus 7, x minus 7. You did it, you're all done. All right. Now we're talking about the sum and difference of cubes. So a good tell is that you have two terms and you have a variable that's the third power. If you see that, 99.9% of the time, you have a sum or difference of cubes. So these are the two formulas for sum and difference of cubes. When you are subtracting, you start with your signs. You start with the same sign, opposite sign, always plus. And then when you're adding, you start with the same sign, opposite sign, always plus. But notice the a and the b never change. A squared never change. AB stays in the same spot. And b squared stays in the same spot. Okay. So when I am looking at y equals x to the third minus 64, again, this x to the third is telling me this is probably going to be the difference of two cubes. So what we're going to do is we're going to set up our little mini equations just like we did with the difference and sum of squares. But this time we're going to use a to the third power and b to the third power. So a to the third power is equal to x to the third because they're in the same spot according to our formula. And then b to the third power is equal to 64. So if a square root gets rid of a power of 3, then we know a cube root gets rid of a power of 3. So we're going to cube root both sides. All right. So we know a cube root and a power of 3 cancel each other out. So a to the cube, when I cube root it, it's a. X cubed when I cube root it is x. B cubed when I cube root it is a b. And then the cube root of 64, that's actually just a 4. So if you need a little bit of help, let's break this down. We know 64 is 8 times 8. And then 8 is 4 and 2. And then this 8's 4 and 2. And then 4 is 2 and 2. And let me cross out the things we broke up. So the number of the root that you're using, so this is a cube root, that's how many of the same number you want in a group. So here we have 3 2's here and we have 3 2's here. So they would come out of the cube root as 2 times 2, which is a 4. So that's how b is equal to 4. You could also use your calculator to cube root, and I'll let your teacher explain that to you if you need help with that. All right, so you have your a, you have your b. Let's move right on to the formula. So we have our first parenthesis and our second bigger parenthesis. So in our first parenthesis, we're going to have a minus b. So our a is x minus our b is 4. And then in our second parenthesis, we always start with a squared. So that's x to the power of 2. And then plus our a times b is in our second slot. So a times b. So if a is x and b is 4, we're asking ourselves, what's x times 4? Oh, well, that's just 4x. And then plus b squared. So b squared, that's 4 to the power of 2. 4 to the power of 2, we know is 16. And then you're all done. You've successfully factored that down. So now let's look at another example. Again, the first question we always ask ourselves is, do we have a greatest common factor? So we have a 4 here and a 32 here. The 32 doesn't have any x's, so the GCF is not going to involve an x. But 4 and 32 definitely have something in common. They both have a 4 in common. So let's divide out a 4. So we have x to the third, and then 32 divided by 4 is 8. And again, we ask ourselves, do we have two perfect cubes here? We know x to the third is a perfect cube, and we actually know 8 is a perfect cube because 2 times 2 times 2 makes an 8. So let's set up our a cubed and b cubed and be on our way. So a cubed equals x cubed, and b cubed equals 8. And again, we're going to cube root both sides of each little mini equation we just did. So we know the cube root of a to the third is a. The cube root of x to the third is x. The cube root of b to the third is b. And we just learned that the cube root of 8 is 2. So once again, we are going to set up our parentheses and get started. Notice that I'm keeping the GCF of 4 outside. It hasn't disappeared. It's just staying out front. So let's do our signs. So it's plus, so same, opposite, always plus. And then in the first slot, we always write our a. So a is equal to x. In the second slot, we always write our b, and b is equal to 2. And we're done with our first parenthesis. In our second parenthesis, we're doing a squared. So x to the power of 2, we know is x squared. The second term is a times b. We know our a is equal to x, and our b is equal to 2. So x times 2 is 2x. In our last slot, we have b squared. We know b is 2. So 2 squared, 2 times 2 gives us a 4. And you're all done. See you in the next video. Just kidding, this is the last one.